First, let's consider the case that if M1 is much larger than M2. If M1 is much larger than M2, we have that V1F is approximately equal to V1I. This is obvious because if you look at this equation, if M1 is much larger than M2, subtracting M2 or adding M2 to M1 change a little value of the result is different very little from M1, right? Because M2 is very small compared to M1. So the ratio here is approximately 1. So we have that V1F is approximately equal to V1I. It means that M1 is almost not changed the velocity. The heavy particle not change velocity. Heavy particle does not change its velocity. However, we have that V2F is approximately equal to the 2 times V1I. Right? This comes from this equation. You can see that since M1 is very big, so M1 plus M2 is approximately equal to M1, and this ratio is approximately equal to 2. So V2F is approximately equal to 2 of V1I. What we have is that the light particle will rebound with twice the velocity of heavy particle. Okay, light particle rebounds with twice the velocity of the heavy particle. So this is a case when the heavy particle move and collide with the light particle that initially at rest. The heavy particle is hardly change its velocity, while the light particle rebound with twice of the velocity of the heavy particle. Next, if the particle that move and collide with the other particle is much lighter, that is M1 is much less than M2, using the same concept, we will have that V1F is approximately equal approximately equal to minus of V1 I. V1F is approximately equal to the minus of V1 I. And this is obvious again because you can see that if M2 is much larger than M1, the ratio here is approximately equal to the minus 1. So it means that the light particle rebound back light particle rebound back light particle rebound back with the same speed. Light particle rebound back with the same speed. So it means that if you have a light particle move and collide with a very heavy particle, it will rebound back with the same speed. This is very interesting if you look at the Japanese cultural sport, that is the sumo, and they also let the small children go to fight with the professional sumo, and when the small children run and strike the very big sumo, he or she will rebound back, while the sumo feel almost nothing. And this is also the result that we will have, that the velocity of the heavy particle is approximately equal to 0. Okay, this is obvious because you can see that from this equation, if M2 is much larger than M1, twice of M2 is still much smaller, twice of M1 is still much smaller than M2, so this ratio is approximately this ratio is very small and we can approximate it as 0. So we have the V2F is very smaller than V1I, or we can say that V2F is approximately 0 compared to the V1I. So we say that V2F is approximately 0. And heavy particle can say that hardly feel anything, or it's not moved. So we can say that it's hardly feel anything. The heavy particle is still there, not move, or move very slowly.